Sir, screen is invisible.
Wait a second.
Yeah, I'll once the stream starts, I'll get going. Okay, I think we are live, so let's start. Is it visible now?
Yes, sir.
All right.
Yes,
Okay.
sir.
In this session, I have, I think, 8 questions written down, and we'll go through the question. I'll give you a bit of time, let's say 5 minutes or so, to see the problem, think about it, and possibly come up with a solution. Even if you don't come up with a solution, you can tell me what you think or where you have confusion. So let's get started. So the first question in this, and the questions are slightly of a higher level than what you typically encounter in practice assignments and so on. I just kept the level a bit higher so that we can go through something which you possibly have not seen. So in the first question, you're asked what are the operations that are closed in the set of natural numbers. So I hope by now everyone knows what the natural numbers are. And then there are certain operations defined on them, right? Addition, subtraction, multiplication, division, exponentiation are five of the many examples of operations that can be defined. So what the definition of closedness of an operation is not given in, it's not part of the syllabus, but here it is explicitly defined. An operation is said to be closed if the output of the operation is always in the set. In other words, if I take two numbers and do the operation, does the answer lie in the set? So which of the operations do satisfy this property is what the question is asking for. So I'll
It
wait
would
for a
be
couple of minutes.
A addition,
Yeah,
multiplication, and exponentials.
yeah, let everyone take their time. Uh, I'll resume discussion at, let's say, 8:16, 8:17.
Sir,
Addition, subtraction, or multiplication.
sir, exponent will be natural number.
The answer is exponential.
There could be multiple answers, so check everything.
A, B, C, and D.
So answer is A, C, and E.
I also go with A, C, and E.
A, C, and E. Sir, A, C, and E.
We are only taking natural number as a base, right?
Yes, the question just said n, right? The natural set of natural numbers.
So only A and C. A, C, and E. I don't think so.
Hello.
Yes.
Sir, I'm sorry to interrupt in between, but I'm facing problem in accessing these meeting links.
If you have the calendar
Yes, sir,
included
I
in
have
your.
the calendar, and in that calendar, I got the link for this meeting. But like 2 hours ago, there was a meeting, like a doubt session of statistics, but that link was not there in the calendar.
You have
Maybe
to
different courses
individually.
handle links differently. So for Math 1, we have it in the calendar. For Stat 1, it may be provided elsewhere.
No, you have to add the links of each calendar individually from each subject's description. Just like you added from maths, you have to add for statistics and for computers and for English.
Hello.
Go at
Sir,
calendar and
probably D and E.
Hello,
Okay,
sir.
so I think that's enough time.
Sir,
So one of you, yeah, go ahead.
sir, at the same time, also, Python class is happening.
At this time,
Yes, sir.
8 to 10, you have Python session also. Is it a TA session or an instructor session?
I think it is, that was a TA session.
Yeah,
The
so what
Python is for the term 2, I guess.
no. So there are people who take Python in term 1, there are people who take it in term 2. It depends on, you have a lot of flexibility, and we cannot avoid all clashes. That's why what we make sure is instructor sessions, there is no intersection at the foundation level, as at least at the Math 1, Stat 1, CT. Oh no, sorry, Python is after CT, right? Yeah. So,
Yes, sir.
but still, we make sure that there are no intersection between instructor sessions. We cannot ensure all instructor sessions and all TA sessions are disjoint. So that is why recordings are also provided in case you miss any of the sessions. In every course, you get the recordings.
So this session is instructor sessions or TA session?
This is an instructor session.
Oh, okay.
sir, where we get notes.
So the notes, so there's a discourse post in the Math 1 subject where there is, wait, let me just check what the title of that discourse post is.
Sir, not showing in supplementary contents.
It's not in the course portal. In the discourse page, there is class notes, slides, and live session tracker.
Sir,
There's a pinned
qualified
post
students
which
might not be in the might not be or are not able to for
access
now
discourse, is
access.
it?
Yes.
Okay, okay. All right, all right. I'll make sure that it is included in the supplementary content in the course portal itself. Yeah. Okay, yeah. Thanks for letting me know. Now let's get back to the problem. So a lot of you said ACE. Does anyone think it is anything else?
A and C.
That
Sir, it might be D and E.
D and E. Okay, so can you tell me why
Because
it is D?
D because
Or just pick up any operation and tell me why it is closed or not closed. Can you explain it to the entire class?
according to me, D would be the answer because while Euclid's division algorithm or lemma, it is said that division by division is where denominator is not equal to 0 and it will be a positive, I think, negative
No,
number.
so sir, division will not be the answer to this because, for instance, if we have two natural numbers, 2 and 3, the division will be 2 by 3, which will not result in a natural number.
Okay, yes, yes, sir. Yeah,
So that is a correct argument.
yeah,
So if you
yeah.
want to say something is not closed, you have to give a counter example,
Okay,
right?
sir.
So 2 and 3 belong to the set of natural numbers, but
Yeah,
when you do the operation 2 by 3,
Sir, I
this
have
does
an
not belong to
natural.
a
Yes,
set
sir.
of natural numbers.
It will be in
Therefore,
point
division
fraction. Yeah,
is not closed,
yes, sir.
right? So can you do a similar thing for addition, subtraction, multiplication, and
Sir,
exponentiation?
2 minus 3 also not possible.
So
So
do you guys hear anything in the background? There's something happening outside. Is there any disturbance?
No.
No,
Okay, then
not
it's fine. Okay,
exponent
fine. So
exponentiation.
let's go option by option. What about addition?
so please explain the questions what it is saying.
Okay, so the question says that an operation is said to be closed. This thing in the bracket over here, it says an operation is said to be closed if the output of the operation is always in the set. Let us look at that in the context of addition. Okay, what it is saying is addition is closed if I take two numbers and do their addition, that sum is also in the set. Is that statement true? If I take two natural numbers and add them, will the answer
Yes, sir.
also be a natural number?
Yes, sir.
Yeah, that is pretty much by definition true. Sum of two natural numbers is a natural number. So to the person who asked the question, did you understand what the question is trying to ask?
Yes, sir. Got it.
Yeah. What about subtraction?
It same goes for the subtraction as well, sir.
Sir, 2 minus 3 not possible.
Not closed.
Not close. Yeah, because it will give a negative integer. Yeah.
I'll
Yes,
just write here plus this 3. Well, we should ideally say natural numbers are closed under plus, but I'll just leave it that way. Once again, we can take the 2 and 3 example, but 2 minus 3 does not belong to it. Therefore, minus is not closed. So what else is remaining? Multiplication and exponentiation. What about multiplication?
It's possible.
Possible. It is
Possible.
possible.
That's possible. Yeah.
What is possible? It is either closed or not closed. What is it?
It's
Closed.
closed.
It's close.
Closed.
Yes.
Closed.
Yes.
Closed.
Yeah. Yeah. Product of two
Multiplication
natural
of
numbers are
two natural numbers are always come inside the set of natural numbers.
Product of two
yes.
natural number is always a natural number.
Sir, I have a
It's the
doubt.
same as. Yeah. Go ahead.
Sir, shall we get the recording of this session or not?
It will be available on YouTube in the IITM BS degree program YouTube channel. There's in the playlists tab, you can get it. Course-wise playlists are created. So you get the, it's being live streamed and it will be available there.
Okay, sir. Thank you.
And the notes, I'll make sure that the link is communicated to you either in some way, most likely in supplementary content. So D is already done. So the last thing that we need to do is
exponential.
Exponentiation. Once again, this is also pretty much by definition. If you have something like n1 and n2, n1 to the n2 is also a natural number.
Natural number, yes.
Right? Because exponentiation is repeated multiplication in some sense.
Yeah,
Yes,
multiplication.
obviously.
So
In the sense
finitely
of
many
in the
times you are
sense of
doing.
power, sir. Right.
Yeah, so this is like n1 times n1 times n1. So this you
Yes.
do n2 times. So
And
each multiplication is closed. So you do n2 times multiplication, it will still be in a natural number. So
Yes.
that is why this also belongs to n for all n1, n2.
Sir, what about 0 to the power 0?
sir,
Well,
argument
that's a
of
good question.
n1, argument of n1 is
That
always
is
greater than 0.
indeterminate form, no?
Yeah, what is 0 to the power 0?
It's indeterminate
It's
form.
more.
It's not determined.
Zero to the power of 0.
There are 7
The
indeterminate form.
convention
It
is
is
to
one of
take
them.
it. Yeah, so probably we have to say that this is not closed because that is not even defined,
Yes, sir.
right?
But sir, 0 to the
So
power 0
that's
is 1, I think.
No, that's not the
No,
case
any
here.
number to the power 0 is 1.
any number to the power 0 is 1, but 0 to the
But
power 0
zero,
is
yeah,
not
yeah.
defined actually.
Yes, sir.
So B option is closed, sir. Right?
So this is not closed because the operation itself is not defined at a single point.
Okay. Like in the case of 0, sir.
Yes. So even over here, in fact, division is not closed. It's not even an operation. So in some sense, the question is not very well formulated,
Yeah, yeah.
but it's okay. So here you cannot have 2 comma 0, right? 2 and 0 are in n, but 2 by 0 is not even a thing. It's not even. It's definitely not in n. We don't define it as some natural number 2 by 0, for example. So division is not closed. You can argue that way also.
So there is a
Yeah.
question to me that in general maths we studied that a zero is not the part of uh, a natural number. It's a whole number. But in IITM lecture, it is included in natural number. Why?
So there are two
Because it is
conventions,
countable.
even among mathematicians. There are people who consider natural numbers to include 0 or to not include 0.
Even
So
include
the
0 also it is
convention,
correct only, sir.
yeah. So
Even including
there
0
are
also
people
it is
who,
correct.
yeah, including 0 is I think the more modern terminology, and that is what is being followed
Yeah,
in this
0 power
course.
4
It
also it is 0.
it might be for computer science binary system 0 and 1. That's why we are including in natural number.
No, even before computers,
Sir, but
this
by
was a topic of
definition, 0 must be included, right?
convention.
Because
This
0
is
is
a
something which is
controversial
countable.
topic, right, sir?
It's not very controversial, but just people have developed
No, sir, but
Okay,
it is
in
something that
certain
is
get
way.
it, sir.
countable.
Get it.
Something that is countable, right? Like there can be zero things, and by natural number by definition is something that you can count.
Yeah, nothingness. Well, that is how you define natural numbers, like as a measure of counting. But there are people who define it just as 1 to 1 and so on. So that's just a matter of convention, and
Yes,
there
sir.
are
Yes,
two
sir. Get it,
schools,
sir.
and I'll just leave it at that for now. That
Okay, sir.
more than that is not required. And for this course, you just take 0 to be included in the set
Okay.
of natural
Okay.
numbers.
Okay, sir. Get.
However, if the
Sir, but
convention was that 0 is not included in the set of natural numbers, then exponentiation would be closed.
Sir, one doubt actually. 0 power 4, if for example, 0 power 4 means 0 into 0 into 0, then it is a 0, right?
Yes.
It will be n only, right? Now, if you consider 0 also, it will be n only. Natural
No, but
number
0
only.
power 0. So closed meaning if you take any two natural numbers, the operation should give you something in the set of natural numbers. That's why
Yes,
we
yes.
are
0.
only
If
looking
we are
at 0.
considering, we are already considering 0 as a natural number. Okay, 0 power 0, you are saying 1.
Yes, that is
Anything
not
power
defined.
0 is a 1. Yeah.
No, 0 power
So
0
then
is
it can
not
be
defined.
okay.
Yes, sir. Can you move
Okay.
to the different question?
Yes, exponentiation is not closed. We leave it
Then
at
the
this.
answer is 1 and C, no, sir?
A and C, yes.
Yes, 1 and C. A and C will be the correct answer.
Oh, okay.
Yeah. Okay, so let's move on to the second question. I won't really read it out loud. You can read it from the screen and think about it, and we'll start discussing at 8:33.
Sir, A, B, and D.
A and B, sir.
Yes, sir. I also think A and B
B,
only.
C, D.
So A, B, and D.
A and B would be the right answer, sir.
A and B.
Why not D?
Sure.
Sir, A, B, and B.
There are people who say it's A,
A
B,
and B,
and
sir.
D.
A and B,
A
sir.
and B.
Only
A
A
and
and
B
B.
only.
Yes, sir. Only A and B.
Any other sets of guesses?
A
Sir,
and
it's
D.
A, B, A, C, and D.
Okay, so there are takers for A, B, C, and D. So let's go option by option. So what's the key point over here? What is a rational number?
Anything
A,
that
B,
can
and
be
C are
written in
correct,
P by
and
Q.
D is wrong.
Because if you take 3 by 4 plus 5 by 2, which is rational, it does not give you a
1 by 2 plus 1 by 2 is 1.
also
Q not
1.
equal to 0 and so on. But yeah, okay. So this is the definition of a rational number. So what happens when you take two rational numbers?
1 by 2 and 3 by
It's
2.
always leads to be a rational.
Rational number, sir.
So do you know how to add arbitrary to rational numbers?
Can you
This would
repeat
just
your
be,
question, sir?
can you,
Q1, Q2
yeah, I
plus
just want to
Yeah,
know
Q1,
if
yeah,
you know
Q2.
how to add.
yes, sir.
Yeah, by Q1,
Q1,
Q2.
Q2.
Q1, Q2.
Now, this may not be in the most reduced form in general, but this is an expression for
Yeah,
the sum
this
of
is
two
the
rational
general
numbers.
expression.
So is the numerator an integer?
Yes, sir.
Yes, it is the integer.
Because P1, Q2, P2, Q1 are all integers,
All
and
integers.
sums and multiples of integers are integers. So the numerator is an
Yes.
integer.
Yeah.
Similarly, you can say or assert that Q1, Q2 is also an integer. So this is of the form integer by integer. And we should also make sure that the denominator is not 0. The denominator is not 0 because individually these are rational numbers which force them to be not 0. So their product is not 0. So this satisfies all the properties that you require to call something rational.
Yes, sir.
So this belongs to the set of rational numbers. Have you been introduced to this notation Q?
Yes, sir.
Yes.
We have been introduced earlier.
Okay. Okay. So this belongs to Q. So this is a statement A is true.
So if
Right?
we take
So
1
what?
by 2 plus 3 by 2,
Yes.
that gives us 2.
Okay. Yes.
2 is not in a P by Q form.
It is 2 by 1.
Okay, in that sense.
Then all natural numbers can be irrational, right? Then so rational. Sorry, all natural numbers also can consider as a
Yes. This is true. All natural numbers are integers and all integers are rational numbers.
Yes, sir.
and all rational numbers are real numbers, all real numbers are complex numbers. So there is a increasing set of inclusions
Yes, sir.
that
Irrational
you
numbers
could.
and rational numbers are called a real number.
Yes. So sum of two rational numbers is rational. Okay. And what about B? There were people who said yes, and there were people who said no. So
Yes,
can
B would be the
anyone?
correct.
B
Yes,
is
sir, I
correct.
can explain.
All right. Go ahead.
Under
Yes,
root of
B is correct.
2 plus of minus times of under root of 2. That means two irrational numbers sum to be a 0, which is a rational
No,
number.
but B is concerned with rational plus irrational.
Oh, sorry. Rational plus
Sir, 2 plus root 2 is 2.
2 plus under root
2 plus
uh,
root 2
2 plus
will
root 2. Yeah,
always be.
it will.
So if you give particular examples,
Sir,
it
if
just says
root 2 plus minus root 2, then will be 0. Then irrational now.
0 by 1 is also a.
see if you're claiming that something is true, you have to argue in general. You cannot give specific examples and says that it works over here. That would be only particular examples. So
So,
or
sir,
the
to explain it in words, if you add a rational number to the irrational number, only the rational number parts add. The irrational number part will remain.
P by Q will add up with irrational number.
okay, so let A be a rational number and B be an irrational number. Q complement. Q superscript C means Q complement.
Yes, sir.
So suppose A plus B is equal to C and C is a rational number. I want to say that this cannot happen. I want to prove that the sum of a rational and an irrational number is always irrational. So I say that suppose the opposite happens, then we have to derive a contradiction, right? This is called a proof by contradiction. So you assume what the opposite of what you want to prove and then derive a contradiction. So what would this equation mean? We'll revisit this a bit. This is C minus A. But what is C minus A? It is the difference between two rational numbers, right?
Yes.
Yes.
What is the difference between two rational numbers?
Difference between two rational number will be a rational number.
A similar argument as the one before will tell you that C minus A also has to be a rational number, but that would force B to be a rational number, which we know is not true.
Yeah, because we considered B belongs to Q complement.
Yes. So we got an equation where an irrational number is equal to a rational number, but we know that they are disjoint sets. So such a situation cannot happen.
Yes, sir.
Do you follow the argument?
Yes.
Yes.
Yeah.
Yes, sir.
So this is not possible.
This contradict our assumption.
This is not possible since C minus A is a rational number and B is an irrational number. There can't be something in a set and in its complement. So here let's start out with, if possible, let A plus B equal to C, where C is a rational number, and then we say that it is not possible. So what is the other case? So we can conclude that A plus B has to be irrational. So this is how you rigorously prove the statement. It is not so important maybe for you guys in this course, since it's not a math course, but still you can appreciate the idea and try to see how you can give robust arguments.
Yes, sir. And and sir, you have proved it in a way that is very easy to understand and most simplest way, because in early times we prove this statement. It's a bit, long language and lot of things assumption. And here it looks so
Okay.
short and clear.
Yeah. So this, yeah.
This
Thanks.
is proof by contradiction,
Yeah.
sir.
This is a proof by contradiction. So let's
Yes.
move on to option C. Product
Sir,
of two irrational numbers.
can you explain the B part again, the complement part?
Okay, so Q complement is the set of irrational numbers. That is fine, right? Like this is rational
Yeah.
numbers, this is irrational. So I
Yes.
take one rational number, one irrational number. I
Yes.
want to know what the sum of these two things are. I
Mhm.
want to establish whether or not it belongs to one of the two classes. So I say, if possible, let it be a rational number, which we will call C.
Yeah, okay, sir.
But if the sum is equal to C, which is an irrational number, I can rearrange the equation and write B is equal to C minus A, as I have done in the next step.
Okay, sir.
If such a situation was possible, then this equation is also possible, which is B is equal to C minus A. But C minus A is a rational number because C and A are rational numbers. Difference between two rational numbers is a rational number.
Yes, sir.
On the other hand, B, we have assumed, we have started out with a B, which is an irrational number.
Yes, sir.
So you can't have those two things to be equal, right? By definition, Q and Q complement are disjoint. There is nothing in both the sets. So this equality cannot happen.
Yes, sir.
Yes, sir. Okay. Okay, that's
So that's why the thing that we started out with, if possible, let A plus B be a rational number, is not possible, is what we have concluded. What is the
Yeah.
only other case that is remaining? A plus B is actually an irrational.
Yes, sir.
Right?
Yeah. Oh,
So this is
thank you.
the proof that rational plus irrational is irrational. Now, what
Mhm.
about the
Okay.
product of two irrational numbers?
It can be rational or irrational.
So B is
Yes,
the
sir.
correct statement. By the way. So is the statement true or false?
False.
False.
Yeah, it's false. So can you give an example? So to say that something is false, you don't need a proof. You need a counter example. You need a set of you need a pair of irrational numbers whose product is a rational.
Root n into root n is n.
Root 2 into root 2. We can say
Yeah.
root 2 into root 2. That is 2.
Root 2 is an irrational number, and root 2 is an irrational number. Well, if you don't want the same numbers, just take something like 2 root 2.
Yes, sir.
But root 2 times 2 root 2 will be 4, which is a rational. Therefore, the statement is false. The statement says that product of any two irrational numbers. So when we say product of two irrational numbers is irrational, we mean that this is true for any two irrational numbers, but we have produced two irrational numbers whose product is actually a rational number. So that statement is false. And what about the last one?
Yes, sir.
It's false too.
Sir, false.
Because if we take
A positive and a negative
root 5
irrational
or
number.
minus root.
So if you take a positive irrational number and the same magnitude negative irrational number, they will
Yeah,
not result.
if you want to produce a counter example, just give specific numbers. You can just do this.
Yeah, I'm sorry.
Yeah. So root 2 plus minus root 2. This happens to be 0. Now, if you don't want 0, you can do anything else also. You can do some p by q minus root 2 and you'll get whatever p by q you want. But the conclusion is that in general, it is not true that the sum of two irrational numbers is irrational. Now, these are just 4 of the possible combinations. You can play around with this more generally and say, now we have done sum of two rational numbers, sum of rational and irrational, sum of two irrational. Product of two irrational we have done. Product of two rational numbers you
Sir,
can
why
do.
D is
Product
not
of,
an answer?
so we have produced two irrational numbers whose sum is rational, right? So, but here it says sum of two irrational numbers is always irrational. We have shown that that is not true.
Oh, sorry, sir. I misread the question.
But even if this was rational, for instance, it would be false. No? You can take something like root 2 plus root 3. So it is not always irrational or it is not always rational. It can be rational in some cases, it can be irrational in some cases.
Yep, sir.
So even if this irrational was actually rational, it would still be
The
false.
answer would be yes, false.
So is this clear to everyone?
Yes, sir.
Yes, sir.
Okay, so the correct options are A and B. Now let's go beyond arbitrary theoretical stuff and let's actually do some numbers. So minimum value of x for which this is a real number. So in general, what does this expression give you? It
3 minus
is
of
not
mod x is
always
always greater than 0.
okay. Just take your time.
Okay.
At 8:50, you let me know what the answer is.
-3 plus or minus 3.
Just a small request.
Yes,
Hello.
please.
Just a small request. If possible, like please take the answer in chat initially. Like it will be give us time to solve.
Sorry, what did you say? What should I do?
Please take the answer in the chat initially, like so it will give others times to solve the question. That's it.
So you mean to say that don't discuss the answer before the assigned time?
Yeah, that I will not. And I cannot look at chat because I'm not on that window. So if there is any doubt, please speak up or please, yeah, unmute yourself and talk. That's okay.
Okay.
Okay, what's the answer?
So -3.
So -3.
-3.
So -3 to 3.
So there can only be one value, and that will be -3. We need just one minimum value.
Yes. According to me,
Yes,
it
sir.
would be 3
-3.
because mod
We
of
need
any
the
value would also minus. If I take -3, that would
yeah,
also
but
give
we need the
3.
minimum value for x, which will be x, which will in turn translate to
-3.
3.
So -3.
Okay. So anyone wants to explain why it is -3?
Yes, sir.
Becomes
please go
So
ahead.
minus 3.
3 minus mod x is
If
a real number. So to be it a real number, it can't be a negative number. So 3 minus mod x is always
So
greater than equals to
what
0.
we, yeah,
sir, if
let me
put
write
minus
what
3
you're
in mod
saying.
x,
3
if put
minus
minus 3,
mod x is
Yes.
greater than or equal to 0
Yes.
for this to be a real number.
Yes, sir.
Is this correct?
Yes, sir.
Yes, sir.
So I need mod x less than or equal to 3. In other words, I need this condition. But
Yes,
what
sir.
is mod x less than or equal to 3? What is the set of all values such that mod x is less? What is the set?
From minus 3
Minus
to
3
3.
to 3.
Minus
Minus
3 to
3 to 3.
minus 3 to
Yeah.
3.
So I can write this as we need x to belong to this interval. Is that fine?
Yes, sir.
So
But
what
sir, the
happens
question
if it is out?
explicitly states that the minimum value for x. So
Yeah.
should
It's not
Answer would be
complete.
3.
Yeah, the answer is minus 3. So the minimum value of x.
Oh, I thought you were writing the answer. Forgive me.
Yeah, this is just the argument. It is still going on. So, okay, fine. Let's write the answer finally. I formulated in this way because the kind of questions that you'll be asked in the exam will be numerical value or options. So we will have to do something like this. So the answer is minus 3 because it is the minimum among all the values present over here. Okay. So what happens if we are outside this set? Outside this set minus 3 to 3, what sort of a number is this called? Can anyone recall?
Repeat, sir.
Complex number.
Please repeat it. What did you say?
So if you are not in the interval minus 3 to 3, then this expression would still give you a number which belongs to a different class. So do you know what that class of numbers
It
is
is
called?
Yeah, we will
Complex
have an
irrational
iota
number.
there. We'll have an
Yes.
iota there, so it will
Or
lead us to
Yeah.
complex.
It will become
Yeah,
a
you will get a
complex number.
purely imaginary.
Complex number.
So actually, it is still a complex number. Real numbers are also complex numbers, but this will be a non-real complex. So it will still remain in this class of complex numbers, but for this interval, it will in particular be real number as well. Okay. So well, even if
Sir,
you
but
didn't get that last part,
if
it's
we
fine.
put minus of 3 in this particular function, it will give us under root of 6.
No, it will give you 0, right?
No,
What is modulus of minus 3?
3.
That is 3.
Mod will give
3
always
Minus 3
positive
plus
value,
of 3.
bro.
Okay.
This is a real number.
Sir,
So 3 minus 3 gives 0.
okay.
Take
Yeah.
plus 3
But-
also, then also it will be 0.
Yeah, so we are not asking for the minimum value of this expression. We are asking for the minimum value of x such that this expression is a real number.
Okay.
Okay, so
But sir,
that is going to be minus 3.
there's a bit confusion to me, sir, that if we take
Okay.
minus 3, so in putting in this under root minus 3 times of taking x as minus 3, the mod will open with extra minus sign, which will become a positive. Then 3 plus of 3 root 6. It's a bit confused to
Okay,
me.
you're saying that this is true, right? So you're using this sort of a definition of
No,
the modulus.
I'm saying that if any number is present in mod, which is negative, that
Yes.
means value of
Yes.
x is negative here in this case, that is minus of 3. then mod will open with a negative sign extra. Then it will open as minus times
So
of minus of 3, which will give
is
to
this
plus
not
3.
okay for you? This expression over here?
Result is
Yes,
plus
sir,
3.
it is okay. It is okay for me.
So then would this not be this?
This is not possible.
And would this not be this? So if I start out with just modulus of minus 3, do you agree
It
that
will
that
be
is
3.
equal to 3?
Yes, sir. I'm just saying
Now
that
if I
yes.
have if you have a negative sign, I'll get a negative sign on the other side as well. Is that also okay?
Yes, sir.
Okay, it is behaving
Yes,
like
sir.
an equation. What we are doing in LHS, we should do the same in RHS.
Yes, you have to do
No, the
that. But
default
even
value of -3 mod is 3 or -2 mod.
so,
That's the default value.
even if I just start out with this, when I remove the modulus sign, I'll just get 3, right? That outside minus sign is unaffected. Or if you are saying that when
Yes.
you're removing the modulus for a negative number, you have to introduce another negative sign. If that is
Yes,
the
sir, and it
convention that
will
you're
become
following,
a
then
oh, okay.
it will become this, right?
Okay, yes, sir. It is the part of the expression, the minus extra minus, and it will, yes, sir, I get it now.
Yes. Okay. So that's real numbers and complex numbers. Now let's go to set theory and Venn diagram representation. So is the diagram clear, and what the shaded region is it clearly visible?
Yes, sir, it is visible
Yes, sir.
clearly.
Yeah. So you are given
It's
a Venn
B.
diagram in its generic, and let me say that multiple answers may be correct. So check which
B.
ones
B, sir.
may be correct.
B.
D.
So are you saying only B?
Yes, sir.
B, C, D.
Give us some
Yeah,
time. B is one of them
let's
for sure.
resume.
B, C.
Let's
Hold on,
let's
guys.
resume
You can
discussion
solve.
at 9-1.
B, C, and D.
Guys, can you hold for 2 minutes, please?
Yeah, even if you get the answer, please don't reveal it yet. At 9-1, we'll take all answers.
Sir, I had a question outside of this, just for a second, if you would allow.
Is it anything related to the question that we're discussing right now?
No, no, no.
Let's take it at the end, maybe. I think we are
No,
on track to
it
finish.
just take one minute, sir. Actually, it's
Okay.
just so this in the exam, if we have multiple options as a part of the answer, and we select only, say there are three options which satisfy the answer, the question, and we select say one or two. So will we be given marks accordingly, or will it be zero in totality?
You will be given partial credit if you have answered only correct options. So, okay, let me just give an example. Suppose there's A, B, C, D, E, and three of them are correct. Let's say B, C, and E or something like that. Now, if you answer B and C and not E, you'll get 2/3 of the total credit. If you answer only B, you'll get 1/3 of the total credit. But as soon as you mark any incorrect option as correct, it doesn't matter how many other correct options you mark, you'll get a 0. So as long as you don't mark incorrect options as correct, you'll get partial credit.
Okay, thank you, sir.
Yeah, because otherwise you can just mark everything, right? Then you can say I marked all the correct options.
Yeah,
So
yeah, yeah. No, understand. Yeah. No, I understood that if we mark any one incorrect, but I just wanted to know for a couple if you have marked two correct and left the third one. So, but thank you for clearing that up.
Yeah.
Discuss it, sir.
Yes, sir. Sufficient time.
We can discuss it.
Let's get to the answers.
B, C, and D.
The B, C, D.
B, C, and D.
All last three B, C, D, I guess.
Anyone who does not believe that BCD is the correct set of options? Okay, everyone seems to believe that BCD is the correct set of options.
Yep, sir.
Sir, only
So
B.
what's the only B?
Yeah, only B.
Okay. So nobody believes that A is correct, right?
No.
Yeah. So if I have a Venn diagram of this sort, something that is in A, in B, as well as in C. So that is A intersection B intersection C. So first of all, the thing that would be in A intersection B is this set, right? So this is precisely where common elements from A and B reside. We want also intersection with C. So we want a subset of that set, which is also in C. So what we end up with is this set. This is A intersection B intersection C. So that's clearly not the shaded region which is given. So this option is wrong. So for B, which seems to be everyone's favorite, it is A intersection, what is the option? A intersection B minus C. So what does the set, let's say, X minus Y comprise of? Can you describe the elements? Can one of you describe the elements
Yes, sir.
in the set X minus
This
Y?
is sign of difference, sir. Like set of all values of X
Elements in
that
A
are not the member
intersection
of
B,
Y.
but not in C.
Just take X and Y. Describe the elements of X minus Y?
Elements in X, but not in Y.
Yes, sir.
Yeah. So that's the simple way to describe X minus
Can
Y.
you go above?
So here your X and Y are A intersection B and C respectively. So I am looking at elements which are there in A intersection B, but which are not in C. Right? So what is A intersection B once again? It is this shaded region. But not only do I want my elements to be in A intersection B, but they should also not be in C. There is a part, the shaded in the A part, what I have shaded lies in all A intersection B and C, all of A, B, and C. So that part I have to remove. So it is just this part, which does happen to be the shaded region over there. Is this clear?
Yes, sir.
Yes, sir.
And now C, and very similar argument for D. Here you have A intersection B minus C.
Yes, it means A intersection B.
It's not just A intersection B, it's A intersection B minus C. So first let's see what's B minus C. So this
Yes, sir.
is once
Okay.
again just A, B, C. What are elements in B but not in C? So I have to remove the part of B which is there in C as well. So I'll be left with this, right?
Yes, sir.
No, no, sir. Yeah, left.
Yes, sir.
Right. If you want it to be more clear, you can see it is all of this.
Yeah,
Yes, sir.
it's
Yes,
more
sir.
Yes, sir.
clear.
So it's in
Values
B
which
but
are
not in C.
which are part of B but not C.
Yeah. The
Okay, sir.
elements which are in B but not in C. That is B minus C. But
Yes, sir.
not
Okay.
only am I interested in B minus C, I'm interested in A intersection B minus C. So among the elements which are in B minus C, I should also make sure that they are in A. So and what is that part? That part would be precisely this, right?
Yes, sir. Right.
Yes,
Yes, sir.
which has been
And that
asked in
also
the
happens
question.
to be this. And a similar argument will tell you that
D is
the
also
other
same.
option is also correct. B intersection A minus C, right? So once again, we'll do the same sort of exercise. Start out with A minus C. That would be this part over here. I'm avoiding C, but staying within A. And then I intersect it with B and I'll get, again, just this. Is that clear?
Yes, sir.
Yes.
So this is correct, this is correct, this is correct. So you can have different combinations of minus and intersection and get same answer, similar answer. In this case, it's not all that different. It's just the difference in where I have put the bracket. But yeah, multiple, there may be multiple ways of
Putting brackets.
expressing the same set using the set operations that you know. That is the takeaway. So there was someone who said that the only correct option is B. Did you realize what you were doing incorrectly? And are you convinced that C and D are also correct?
Yes, sir.
Yes, sir.
So I wanted to ask a question that
Yes.
this method of analyzing Venn diagram, when it comes to solving the word problem, which is based on these things, I personally feel that sometimes the region which are collapsing with other sets, which is represented this type of Venn diagram, will not fit with the um, with the problems of the question. I think it will go
Do
like
you have
a
any
formula
specific
for.
example?
Yeah, there would any question in this week assignment. Right now, it's not okay. Yes, I don't have any example right now which I can, but it's on my laptop, I think.
So when you have a three set problem,
Yes, sir.
are you talking about like cardinality of A
Yes, sir.
union, B union, C,
Yes, sir.
that sort of
Yes, sir.
thing?
I'm asking. Yes, I'm talking about those type of problem. There is just
Okay,
like a
so
formula-based approach also to this thing. But I am comfortable with
so
this Venn diagram
right.
solution. But I feel sometimes it get stuck when problem become complicated. Like this, three sets are involved.
So are you finding it difficult to visualize this formula through a Venn diagram? Is that what you're saying?
Yes, sir. It is what I wanted
It is
to
part of the
say.
problem. Okay, yeah. So what is the set of a set A union B union C. It is something that could be A or B or C. So
Yes, sir.
what do I do in the first part of the formula is I add all elements of A, B, and C. But
Yes, sir.
clearly I'm overcounting over here, right? So when I'm adding elements of A as well as elements of B, the elements that are in A intersection B, I'm adding twice.
Yep. Yes, sir.
Do you realize what I'm saying? Do you understand what I'm saying?
Yes, sir. We
So
are
there is some
adding two
overcounting.
times. Yes, sir.
Yeah, we are adding at least 2 times. Like it might be in C also. So we may be adding it 3 times also. So
Yes, sir.
yeah. So this part does give you a larger number in general than the number of elements in A union B. So if I take these guys apart, right? So I have added A plus B plus C. But
Yes,
what
sir.
I have overcounted is this for sure. So I've added this thing twice. So I remove it once.
Yes, sir.
Then I realize that I have added this part twice. So I remove it once.
Yes,
Or
sir.
this part, whichever is your favorite thing.
Yes,
So
sir.
I
Right
remove
now.
all the things that
Repeated
have been
parts.
added twice. I have removed once. But what happened to this part? This common part? I added it 3 times when I added A plus B plus C, like the cardinality of A plus cardinality of B plus cardinality of C. When I did that, I added those elements 3 times, once in A, once in B, once in C.
Yes, sir.
Correct?
Yes, sir. Correct.
But then when I removed elements from A intersection B, B intersection C, and C intersection A, I removed it also 3 times.
Yeah. To balance, we remove it also. Yes, sir. We remove 3 times because we have earlier added it 3 times.
We have added 3 times and removed 3 times, meaning those elements are
Remain
not
same.
counted still.
Yes, sir.
See here when we did this, elements in A intersection B, for example, we added 3 times. We added 2 times and removed it once, so that at least once it is represented.
Yes, sir.
Right? But what happened to elements in A intersection B intersection C? We added them 3 times, removed them 3 times, meaning those are not yet counted.
Yes, sir. Those are not represented. Yes, those are not counted.
So that's why I added this part as well.
Oh, now I get some. I have a clear visualization of what actually this intersection formula fit on the Venn
Yes.
diagrams.
So in the 2-dimensional case, it is very simple. I add
Yes, sir.
these elements, I add these elements. I have repeated this once, so I just remove it. So it's just A plus B minus A intersection B. But over here,
Yes, sir.
many more intersections are happening. There's a pairs of intersections and there's triples of intersections. So you have to keep track of all that. And this is still an intuitive proof. Now, what happens in the case of 4 sets? A1 union, A2 union, A3 union, A4. That becomes a even more complicated formula. So if you are interested in things like that,
Yes.
this is not for the course, but if you are interested in stuff like this, you can look up something called inclusion exclusion principle. It's a very
Okay.
fundamental thing in combinatorics. So this is not for the course, but just for extra reading if you have the
Yes, sir.
time and the enthusiasm.
And sir, right now I just get the question which I feel to be very difficult while doing this kind of stuff. I have that question. Can I ask, sir?
Let's take it at the end, maybe.
Okay.
I have shared one question. If you can take up, I've shared in the chat. It's on set theory.
I cannot see the chat right now. Once again, we'll take that at the end. Is that fine?
Okay. It's totally fine, sir.
You can just read it out to me later and we'll take that up.
It's a very good question. Can I read it out now?
There's just 3 more questions. Shall we go through that? And 4 more questions, actually.
Okay, sir.
भाई बाद में पूछ लेना
Okay, I will definitely take it up at the end. let's quickly go through the things that I have already written down. So now, abstract definitions of sets. I hope you're all comfortable with this A mod B notation.
Sir,
So
why have you put mod 2 in bracket?
that is one of the ways we usually do it.
But in
Does the prof not
general, in
do
all
it?
the question, it's just normal x mod 2. I mean, I'm sorry, it's
So,
a
Okay,
stupid
will
okay.
it be a
question.
modulus function or a modulo function? I think it's a modulo function.
It's modulo. So A mod B
Yeah, it's
is
modulo
equal
function,
to
sir.
K is the same thing as saying A divided by B
A
gives you
divided
K
by
as
B
the
is,
remainder.
yeah, yes, sir. It's a
K is the
different from
remainder when
modulus function, sir.
it's different from modulus function, yes.
Huh.
So this is modular arithmetic.
Yes, sir.
So here I've considered the set of integers such that x mod 2 is equal to 0. So it's described in this way. And can you decode what it actually means and describe the complement of that set? That is what the question asks. Once again,
Okay, sir.
we'll
We
resume
are trying
discussion
to.
in a couple of minutes.
Okay, sir.
Is that enough time? Can we
For
discuss?
A and D.
Yes.
A and D,
A
sir.
and D.
The answer
A
is
and D,
B and
sir.
C.
So it would be
Sir,
B. It's a
Sir, B
complement
and
stop.
of
C.
Sir,
It's
Sir,
B
B
B
and
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 C.
C,
B and
sir.
C.
B
Sir,
and
B
C.
and
B
C.
and
So
C.
B and C is in question complement.
Sir, A and D.
B
Sir,
and
B and
C.
C.
Okay, so
He was
can one
asking
of you
about
say
complement of A.
So this is a set
what
of
the
all
set
even
A is?
numbers.
B and
It's a
C.
set of even numbers starting from 2, which are divisible of 2, multiple of 2.
Yeah, it need not start from 2. It could be negative as well. But
Yeah,
can
it's
you
divisible by 2.
quickly? Yeah,
divisible
it's
by 2.
divisible by 2 is correct. So divisible by 2
D
meaning
is divisible by 2.
it's an
These
even
are
number.
even, yes. Even set
Yeah,
of even
so
integers.
let me write that down. What does, so let me not put the bracket if that is confusing. X mod 2 is equal to 0 means
X by 2 gives
we
remainder
get
0.
a remainder 0 when x is divided by 2.
Yes,
So
sir.
what sort of integers give 0 remainder? So when you divide by 2, what are the possible remainders?
0.
When you divide any
0, 2,
integer,
4, 6.
no. When you divide any integer by 2, what are the set of all possible remainders?
So 0 and 1.
0 and 1.
0 and 1, right? So when do you get 0? When it is an even number. And when do you get 1? When it is an odd number.
Odd number. Yes.
So A is actually the set of even integers. All right. But what is asked is the complement of A, as many of you pointed out. So what is the complement of the set of even integers in the set of integers?
Odd
Set of
integers.
integers.
B and C.
They're odd.
So the complement of a set cannot be itself. So this is wrong.
The
Yes, sir.
Set
complement
of
of
odd
Complement.
integers
even
is
are
correct.
odd.
Complement of A.
Question ask complement. That's why B and C is right.
Yes.
Yeah. So one way to say that this thing is odd numbers is also using modular arithmetic notation, saying that if I divide x by 2, then I'll get 1 as the remainder.
Opposite
And
of the
this is
correct
just,
answer, sir, right?
sorry.
Opposite to the correct answer, right?
So B and C are the
No,
correct
actually the
answers.
correct
So
answer
you
is
won't
B and
complement.
C because it asks about the complement. So yes, it's right, B and C directly, not opposite.
Yeah.
Yeah, not the set B and C, but the options B and C are correct.
Yes, sir, B and C option.
Yeah, is that clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Right.
What option D represents?
That is again even integers, no? So if you can
Even
write something
integers.
as 2 times some integer,
Okay.
then it could be
Yes, sir. It will be
plus
even
minus
also.
2, 0, plus minus 4, so on.
Yeah.
So
Okay,
that's
sir.
again even integers. So A and D are actually the set A itself, and B options
Yeah.
B and C are A complement.
Sir,
Yes.
there's
Now
a
this is
question.
this sort of binary classification happens only because here you have mod 2. So take this as an exercise maybe. What if A tilde, I'll just call it A tilde, X Z such that X mod 3 is equal to 0. So how would you describe its complement, or how would you describe this set itself?
This set will include the multiples of 3.
Yeah, so it will be multiples of 3 and the complement will be not multiples of 3. But then that set will have remainder 1 or 2. In this, such an option will not be there. An option similar to
Yes.
C will not be there. It will
Sir,
be this or something.
yes, sir.
Yeah.
Sir, when we divide by 2, the remainder could be 1, 0 or 1. When we divide by 3, the
Yes.
remainder would be. Sir, how we get those things? I'm just, not remembering that concept, that how this remainder are. Remainder basically it's Euclid's division lemma. Will that be applicable here?
Yes. 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 The integer can be written as 3q plus r,
Oh,
where
yes, sir.
r
Thank you.
is less than or equal to 3, like 1, 2, or 3. 0, 1,
Yes,
or
sir.
2. Sorry. In modular arithmetic, it's 1, 2, or 3, but yeah, 0, 1, or 2.
Yes, sir. Now I get memorized what I have
So
studied.
you have this class of integers which are of the form 3q, which is the same as saying x mod 3 is equal to 0, or it is of the form 3q plus 1, which
Yes,
is
sir.
in the modular class of 1. All these are slightly advanced terminology. So just take this as an
Yes, sir.
exercise if you
Okay,
want
sir.
to do something slightly more complicated. So question 6 I will return to, because I've not written down exact numbers. I wanted to write down exact numbers, but then I did not. Probably one of your questions will be along the same lines. So I'll return to it at the end. This actually has to do with having numbers and 3 sets, pairwise intersections and triple intersections and so on. That I'll come back to later. Now we'll go to
Okay, sir.
relations. And here I've actually used mod 3 and examine these properties, meaning determine whether or not the relation that is defined over here is reflexive, symmetric, or transitive? Which of the properties actually are satisfied? I think there was one person in the last session who said that when the relation is listed out, the elements are listed out, we find it easy to check the properties, but when it is described in words, it is not. So this is one question where it is described in words, not exactly words, but it's described not as explicit listing of elements. So try to understand this and see whether the relation is reflexive, symmetric, or transitive. Whichever properties are satisfied, you let me know at 9:30. We'll resume.
Sir, it will be all reflexive, symmetric, and transitive.
So it's an equivalent
Yes,
relation.
sir.
The reflexive and symmetric. Reflexive and symmetric.
Sir, all three. Because, sir, 1 minus a minus a is equal to 0 divided by 3 equal to 0 always. And uh, a minus b and b minus a divided by 3 always is same answer given.
Yes, and transitivity.
And sir, a minus b equal to uh, uh, divide by 3 is multiple of 3, and b minus a also divide by 3 multiple of 3. Then a minus c will be add 1 minus b divided by 3 or plus b minus a divided by 3 given 3 multiple. So
Yes, I'll write that down clearly. It is an equivalence relation, is the conclusion, and which means it is reflexive, symmetric, as well as transitive. So did anyone find it difficult to comprehend, or if there is someone who is finding it difficult to understand the problem, please let me know.
No, sir, easy.
Easy, sir.
Just one second. Yeah. So for reflexive, what is it that we need to check if something is reflexive?
Sir,
Should
it is
contain
same
A,
to
comma A.
equal to itself.
This is what we have to check, right?
Yes, sir.
So when would A comma A be in R as per the definition?
A minus A
Divide mod 3 equal to
divide by 3. Divide by 3.
A minus A mod 3. What is A minus A mod 3? It is the remainder when 0 is divided by 3, which is 0.
Yes, sir.
If you want one more step, we'll just write this. Right, so this is true. So yes. For all A and Z. And then for symmetry, so in this problem, may not be when you're doing it under time pressure, but it is also simpler to reformulate the question. When does A comma B be in the relation if A minus B is equal to 3K for some K, an integer? Do you agree that this is an equivalent formulation of the relation?
Yes, sir.
Yes, sir.
So if A minus B is of the form 3K, then A minus B, when you divide by 3, you will get K, which
Can't
is
understand the step.
Constant.
Could you repeat? I couldn't hear you.
Can't understand A minus B equal to 3K.
So what does A minus B mod 3 equal to 0 mean? If I divide A minus B by 3, I'll actually get an integer, right? Because the remainder is 0.
Yes, sir.
Yes,
Okay,
sir.
sir.
Right.
Is that fine?
Yes, sir.
Yes, sir.
So I just rearrange this and I get A minus B is equal to 3K. So what are the
Yes,
sort
sir.
of numbers which give you remainder 0 when you divide by 3? They're precisely multiples of 3, right? Like 3, 6, 9, plus or minus, all of those guys.
Yes, sir.
Only those guys will give you remainder 0 when you divide by 3. That is why A minus B mod 3 is equal to 0 is the same as saying A minus B is a multiple of 3, an integer multiple of 3.
Yes, sir. And integral
So,
multiple of 3.
yeah, and that is the same as saying A minus B is 3K for some K integer.
Yes, sir.
Is that okay?
Okay,
It's
sir. Thank
okay,
you.
sir.
Yeah. So why did I do this? Symmetry and transitivity, I can write more cleanly if I reformulate it this way. So suppose A minus B or A comma B belongs to R. I need to show that B comma I also belongs to R. So I'll just write A minus B is equal to 3K. Since AB is in the relation, A minus B is a multiple of 3. So I'll get A minus B is equal to 3K for some K. But what does this mean? What would B minus A be? This
Minus
is
times
just
of
3
3K.
times minus K.
Yes, sir.
So which I'll just call 3K prime just to keep it in the same format as the
Yes, sir.
previous one. But this is the same as saying B minus A is 0 mod, B minus A mod 3 is 0, or B comma A is in R. These are all implications.
Yes, sir.
Is this fine?
So,
Yes, sir.
Yes, sir, it's fine.
so,
Yeah.
so we'll put the value of A and B to be 6 and 3, then only we get the modulo is 0. If it is take the value of 3 and 4 at the place of A and B, and at the place of B and C will not get the, at the place of B comma A, if we put the value of 4 comma 3, in that situation we'll not get the value of, means modulo of 3 to be 0, isn't it?
So you started out with 3 comma 4, right?
Yes, sir. Yes, sir.
So this is not in the relation because 3 minus 4
results to 1.
This is minus 1.
Yes.
Oh, sorry.
Can you
It's
explain the
minus 1.
example -4 to +4?
Just one moment. So the element that you started out with itself is not in the relation. This 3 comma 4 is not in the relation. So you don't need to expect 4 comma 3 to be there. For symmetry, what is required? I start out with an element in the relation, then its symmetric counterpart is also there in the relation. That is what your symmetry condition says. A comma B belongs to R implies B comma A belongs to R.
Yes, sir.
Yes, sir.
Did you understand?
Yeah, yes, sir.
Yeah. If you want to work with examples, instead of taking 3 comma 6, you could even take something like 4
5
comma
comma
7.
Yes.
Okay, so 4 comma 7, does it belong to R? 4 minus 7 is minus 3. Now this mod 3 is 0. When I divide it by 3, I'll get minus 1, which is an integer. So this
This is the part of the
implies
relation.
that this is in R.
Yes, sir.
And what about 7 comma 4? 7 comma 4 also, if I do this, 7 minus 4 mod 3 is the same as 3 mod 3. What is 3 mod 3?
That is also
That is also 0.
That is also 0.
Which would implies 7 comma 4 is in R.
Yes, sir.
So whenever you have
example like -4 and -1, -3 0, the difference of 3, -2 1 and 0 3. So on the basis of that, I can't see any like reflexivity. I can't see
reflexivity
like
requires
-4
elements
-4.
of the form AA to be there.
So I can't see any -4 -4 in the pair or -3 -3 in the pair.
-4 is does belong to R, right? So okay, let's take this as a side question. Particular example, does -4 belong to R? What is the difference between -4 and -4? -4 minus -4. So this is A minus B, and that is 0. 0 by definition is 0 mod 3, or 0 mod 3 is 0.
Okay.
Is that fine?
Yeah.
So is reflexivity and symmetry clear for everyone?
Sir, that 4 minus 7 is equal to mod 3. How it belongs to R? Can you explain again? 4.
So when do you say A comma B is in the relation? By definition, if it is of the form 3k for some integer k, or more straightforward, or the first definition as per the question is A minus B mod 3 is equal to 0. So let's compute what a minus b is. And we found that that is minus 3.
बोलो
So minus 3 mod 3
ठीक है मेरा क्लास चल
is
रहा है
0. So is this statement clear to you?
Okay, got it.
So what is minus 3 mod 3? It is the remainder that you get when you divide minus 3 by 3.
Okay.
Yes, sir.
Which is 0, right?
No, it means minus 3 divided by 3 is equal to 0. Then it will be minus 1, right? How 0?
No. It's not the quotient. It's the remainder.
It's
So what is
it's
4
the
mod
remainder.
3?
Okay. Sorry, sir. Okay.
Yes,
4
sir.
mod 3 is 1. Why?
Yes,
Because
sir.
when you divide 4 by
Got
3,
it, got it, sir. Yeah.
you will
Got
get
it.
1
Yeah,
as the remainder. So multiples of 3 leave 0 as the remainder. Okay. So that's about symmetry. And the last thing is transitivity. That was also explained, and I'll just write it down cleanly. Suppose AB and BC are in R. So what does this mean? This means that A minus B is some 3K1 and B minus C is some 3K2 for some integers
Yes.
K1 and K2. So this is that alternative formulation. Even if you use the modular statement, you can prove this. Then you add these two equations. What will I get? I'll get A minus B plus B minus C is 3K1 plus 3K2. Now the B's get cancelled out and I'll get A minus C is 3 times K1 plus K2, which is an integer. So A minus C is also a multiple of 3.
Yes,
In other
sir.
words, A minus C mod 3 is 0.
Equal to 0.
Or,
Yes, sir.
which is again the same as saying AC is R. AC
Yes,
is in R. So transitivity is also done. You can take particular
equivalent.
examples to see it even more clearly. If just symbolic math proofs you're seeing for the first time, it might be a bit
4,
intimidating.
7, 10.
So yeah, you can take whatever pairs and I'll leave you to it.
Sir,
4,
so we
7,
can
10.
use similar methods for questions like this too?
What methods?
Like we are assigning A minus B is equal to 3K1 and 3K2. So if we get other questions like this too, can we use this method?
Other questions like this, meaning if it is modular arithmetic, you can always, if it is 0, you can always equate it to whatever, n times some integer if you're doing modulo n. Is that what you are asking?
Yes.
Yeah, if you have something of the form a mod n is equal to 0, you can say that a is equal to nk. These two are equivalent statements.
So is this method, which is a general method, is while solving the questions like this or related to this in examinations, can we use this approach to solve the question fast, or we can take the arbitrary examples like numbers 2, 5, this kind of thing?
So examples, you can, since this is an infinite set, you can't possibly consider all examples. So
Yes, sir.
in
Yes,
some
sir.
sense, by definition, this is faster. But
Okay.
if you
Get it, sir.
find a practical way to consider nice examples, and if you are in a hurry and if you want to guess, maybe that is fast. If you want to just consider like quickly 2, 3
But
examples and base
yes,
your
sir.
guess on that. Let's say you have very little time remaining and you don't want to
Okay.
go to construct all the correct proof.
Get it,
So
sir. Get it. But this generalization will always lead me to a correct answer.
yes, if you get a proof, if you logically follow what you have to what you get, then that is a complete argument, as long as you don't
Oh,
make any logical fallacies in
get
between.
it, sir. Get it, sir.
Yeah. Okay, so this is about relations, and the final question, barring that question 6, is this one, where we have this is again not the sort of question that you would get in the exam, because in the exam you would probably get which of the following is the largest possible domain for the real valued function, and you'll have 4 options. So here I've just left it like this. You can work it out. It'll be in terms of an interval or a union of 2 intervals. So 950. Let's start discussion at 950. Give me the description of the largest possible domain for this real valued function.
Sir, it will be 1 or -1. So 1.
Yeah, let's wait until 950.
Yes, sir. Sir, this is last question.
Yes, and then there's a couple of questions that people want to ask, so we'll take that up.
Okay.
Okay, so what are the answers?
X -1 and
Sir, +1. Minus +1, sir.
X belong to
Sir, +1 because
+1
largest possible
to
domain.
1.
Largest.
The largest possible
Large.
domain is a set, so it's not a value. I'm looking for a set.
Yep, from -1 to 1.
Sir,
Open
-2,
interval of
-1 to
-1 to 1.
It
What
belongs
closed?
to
-1 to 1?
Open bracket.
Open or closed?
open bracket.
Right. So
yes, sir,
anyone
open.
wants to give the argument why this is the correct answer?
Yes, sir.
Uh,
1
Please go
minus
ahead.
1 minus mod of x greater greater than 0.
Sir, when we put 0, it get infinite.
When you put x
Would be
equal to 0,
not
it's not
equal to
infinite.
0.
So
It
usually
will be
under the square
close
root,
bracket.
I need this condition, right?
Yeah.
Yes, sir.
But then again, this is in the denominator as well.
Not equal, sir.
Cannot be 0, the denominator.
So I want this also, which of course I can write together as just this.
Yes, sir.
It would be close bracket, sir.
Which no, it will not be closed bracket, because if x is equal to 1, then the denominator will become 0, and then you will have not a well-defined number, real number. Is this clear?
Yes, sir.
Yes,
Sir,
sir.
I have a doubt. -1 less than or equal to x less than or equal to. In that method also we can solve it, no?
Yeah, this is the same thing, right? So, but less than or equal to is a problem, but this is the same thing as this, right? So interval meaning all values in between, which is the same as saying x is between -1 and 1. But equality is something that we are avoiding, because if you plug in that, the denominator would become 0, and that is not allowed.
Okay, sir. Thank you.
So you're right in saying that if we start out with this, then you would get -1 less than or equal to x less than or equal to 1. But that is not all that we want. We want this to be greater than for the square root to make sense, we want this condition. For the denominator to not vanish, we want this condition. And both the condition need to be satisfied for the function to be
Yes, sir.
well defined, and for the codomain to be a real value, real numbers. So we want a real valued function. That's why we are avoiding these two things: the negativity of the square root, and as well as the 0 of this term under the square root. So
Yes,
we
sir.
only want positive terms under the square root, strictly positive, which would lead us
Yes,
to
sir.
this domain, which is the open interval from -1 to 1. And by definition, open interval means all values greater than -1, but not equal to, and all values up to +1, again, not equal to. All right.
Yes, sir. Thank
Yes,
you.
sir.
So before going to question,
In this case, the range has to be minus infinity to 1, isn't it?
okay, that's a good follow-up question. Let's do that. What is the range of f if the domain is this? Let's not wait for people now, because we're already kind of running out of time. Does anyone have ideas how to approach this?
Sir, 1 and infinite. Sir, 1 and infinite.
So first of all, you observe that this is a positive function, right? So this is a 1 by some positive number. So
0
it's
to
of course a
infinite.
positive. So there's people who say 1 to infinity, included or not, I don't know. There's 0 to infinity. Which one of them is correct? Or is it something else?
What a closed interval of 1, sir.
Closed interval 1 to infinity.
Sir, 1 to infinity.
Yes, sir.
Yes, sir.
Last one.
The last one?
Yes,
Yes,
sir.
sir.
Yes, sir.
Can you explain?
If we put 1 in the x place, means the 1 minus 1, 0. 1 by 0, it gives infinity.
And when we put a 0, then we get 1.
Yeah, but why would it not take any value less than 1, for example? Why is it not something like this?
Sir, less than 1 minus 1, when we get so infinite, then we get infinite.
So the right way to argue would be, if I want to find the minimum value of a fraction, what should I do about the denominator? The numerator is a constant, so I don't care. If I want the fraction to be minimum, I want the denominator to be maximum, right?
Yes, sir.
So I want the maximum possible value for 1 minus mod x. Square root is a increasing function. Or let's just keep that square root as well. I want the maximum value of this expression in order to get the minimum value that f takes. What is the maximum value of this expression?
1.
When does the maximum
And
value of
maximum
that
value is
expression?
1.
Sir,
It is 1.
x value is 0.
Yeah, when x is equal to 0, because you are taking 1 and subtracting something positive, non-negative. So, and
Yes.
that thing can be maximized only when the thing that you're subtracting is minimized. So you have to minimize this guy, and the minimum value of the modulus of x function
Plus or
is
minus 1,
at x
sir.
equal to 0. No, you want to
Minimize.
maximize this function. In
Minimize
order to
value for
maximize
x
this
is equal to
function,
0.
you want to minimize mod x. Minimizing mod x happens at x equal to 0.
Yes, sir.
So, and at that point, the function value will be 1. I have just said it out, said it and not written it as neatly as I've done the other problems before. But I hope you are following my argument.
Yes, sir.
Right. So the minimum value is 1 and maximum value is infinity. You can see by taking values close to
Minus
1.
1 and 1.
Minus 1 or 1. It's symmetric
Yes,
about x. So it doesn't matter what you take. For example, if I take something like 1 minus delta, let's say delta is a very small number. At x is equal to 1 minus delta, what is f of x? F of x is 1 by square root of 1 minus delta, which is the same as 1 by square root of delta. And delta is a number that can be as small as you want. But as the value of delta gets lower and lower, what happens to the value of f of x?
is increased.
It shoots up, right? The closer I am to, so if I take something like 10 to the power minus 30, I'll get 10 to the power 30 as the function value. And if I go even lower, I'll get even higher value when I take the reciprocal. So I can make
Yes,
my
sir.
function value arbitrarily high as I want by taking a very, very small delta and considering
Yes, sir.
the function value at 1 minus delta. So on the one side, it is unbounded. It can take as large a value as you want, but the minimum value is not arbitrarily small. It cannot go below 1. And 1 is actually attained at x is equal to 0. So this is the correct answer.
Yes, sir.
Okay. So there was questions in the chat or anything else. We'll take up a couple of them and then we'll wrap up.
Question on the chat on set theory on tigers. It's a very good question. If you can take it up, it would be.
Could you read it out?
Just a
Sir,
second. Give me a moment.
sir, I have a doubt.
Can we get to that after this?
Should I read it out?
Yeah.
In a zoo, there are 6 Bengal white tigers.
Okay.
And 7 Bengal royal tigers. 6 Bengal white tigers and 7 Bengal royal tigers.
Okay.
Out of these tigers, 5 are males.
Okay.
And 10 are either Bengal royal tigers or males. obtain are either Bengal Royal Tiger or males. Find the number of female
Okay.
Bengal white tigers in the zoo.
Okay, good. Then I don't have to go to question 6. So you want female?
Female Bengal white tigers.
So, right, female and. So or is usually, or is union and is intersection. I hope you know that, right?
Yes.
So here
Yes.
you have 4 classes, right? So there's A1. I'll just call this A1, A2, B1, B2.
This is graded
This
assignment.
is not.
Week 2?
Is this a graded assignment question?
I'm not
Yes.
sure.
Yes,
I haven't
sir.
seen the
Yes,
graded
sir.
Yes,
assignment.
sir. Yes, sir.
Okay.
Then we'll not discuss this.
Okay.
Sorry.
Okay.
Graded assignment
Because
question,
it
sir.
was in the last, because it was in the set theory of last year. So in the September term.
Okay, okay.
So I remember this. Anyway.
Yeah, if you can not solve it even after the deadline, then you can write to
Okay.
me or make a discourse post or something like that.
Okay. I haven't checked
Sir,
the
I have a
week
doubt.
yet. Yeah.
Sir, I have a doubt that one question. There was one question in practice assignment.
Okay.
So
Can you give me the
natural
number?
number, sir, natural number 0 when taken 0 with 0, the answer is 35, and when without 0, 34, and correct answer is 34.
Okay. Can you tell me which question this is? Is this in the week 1 practice assignment set?
Yes, sir. I not remember that
Can you?
question.
Sir, I
but-
think that is in a assignment, graded assignment question.
If it is in the graded assignment, once again, I cannot discuss it.
Problem in a percentage, how to solve, sir? Set theory.
You will have to give specific examples.
In the
I
chat
don't quite
box,
get it. You have to read it. I cannot
in
go
a
to that
city,
screen.
shall I read?
Okay. Yeah, sure.
In a city, 40% people like only one fruit.
Only one fruit, is it?
Yes, sir.
Okay.
35% people like only two fruits.
Okay.
20% people like all the three fruits.
20%, is it?
Yes, sir.
Okay,
People,
there are some 3 fruits. Okay.
yes. How many percentage
Okay.
of people do not like any one of the above 3 fruits?
Okay. So here I can tell you, using Venn diagram also you can do this. You have people who like this, people who like this, people who like this, and there are people who don't like any of them. So assume that there are 100 people in the city. Okay, so your universal set has 100 people. If that is the case, then do you know what is the region represented in the Venn diagram which captures only one fruit? So let's say this is people who like fruit 1, fruit 2, fruit 3. If someone likes only one fruit, what is that region? What does that region correspond to?
1.
It's not just 1. It can be in 1 and not in 2 and 3, or it could be in 2 but not in 1 and 3, or it could be in 3 and not in 1 and 2. Right? So it is.
100%.
So I'll call this guy A1, A2, A3. These 3 sets I'll call A1, A2, A3. So what is the set A1 minus A2 union A3? These are the people who like only
One
fruit number
fruit.
1.
Yeah.
The first fruit. A2 minus A1 union A3, that consists of people who like only the second fruit, right? A3 minus A1 union A2 is the set of people who like only the third fruit. Is this much clear?
Yes, sir.
So what happens if I take A1 minus A2 union A3 union A2 minus A1 union A3 union A3 minus A1 union A2. This is the set of all people who like exactly one fruit. It may be fruit 1, or it may be fruit 2, or it may be fruit 3. But they like exactly one fruit. Is this clear? So what's actually A1 minus A2 union A3? You want it to be in A1, but you don't want it to be in A2 or A3. So that is exactly this set. You're avoiding both A2 and A3. So the people who are in this now shaded region would be the people who like only fruit 1. They don't like fruit 2 or fruit 3. Is that clear?
Sir.
You will, if it is not clear, you have to tell me so I can slow down. I can take it again.
So are we solving for people who like one fruit A, fruit B, or fruit C, or like one fruit, two fruit, or three fruit?
We would like to know the percentage of people who don't like any fruit.
Okay.
Okay. So what is this set?
A2 minus
Well,
A1 union A3.
right. So these are the set of people who like only fruit 2.
Yes, sir.
And now what I'm shading is the set of people who like only fruit 3, not
Yes,
fruit
sir.
1 or fruit 2,
Yes,
which
sir.
I have written as A3 minus A1 union A2. And this, whatever color this is, teal or whatever, shaded region, together, all three of them together contains all the people who like exactly one fruit. Right?
Yes, sir.
Yes.
Now let's take two fruits, exactly two fruits. What is the set of people who like exactly two fruits? So either they like exactly the first and second fruit. They would
Yes,
be in
sir.
this intersection, but they would not be in the common intersection. They would avoid A3, right?
Yes, sir.
Yes.
And now if you take A2 and A3 and not A1, so that
Yes, sir.
would be this
Yes,
region.
sir.
And A1
And
and
A1 and
A3 and not A2 would be this region.
yes, sir, definitely.
Right. So, and that blue shaded region, all three together, that comprises 35%. That is 35% of the people. What color do we use? Yellow. Okay. So that would be a bad choice. Red is good. Now, what are the people who like all three? That would actually be the intersection of these three sets, which is that central region.
Yes, sir, 20%.
And all of these things are disjoint from each other. So the total thing, if I add up 40%, 35%, and 20%, what I obtain is people who like fruits, which makes up
95%.
95%. So there's just 5% of people in the complement of this. Right? There is a way to solve this symbolically making it proper, but even just Venn diagram and using this logic is sufficient to get the answer.
Sir, what the question is asking, sir?
Okay, that maybe we had to write in the beginning. What is the percentage of people who don't like fruit, any fruit?
Then it would be 5%, right, sir?
Yes. So in this case, things are simple because you have been given disjoint sets. Right? People who are in this 40% cannot be in this 35% because this is exactly one fruit, this is exactly two fruits, this is exactly three fruits. Now, something more tricky and something that you can try later is if it says at least one fruit over here, at least two fruits, then you would have some intersections and you'll have to find out this exact percentages and then solve the problem.
The question which I raised is not in the week 2 graded assignment. I just checked. I'm not sure
It should be in week 1 graded assignment if it is there.
Week
right?
1 I've already
It's
No,
appeared,
sir.
so it's
No,
not
sir.
there.
That question not a graded assignment.
I'm not
You have
sure if
to-
I'm like I can't see that in the graded assignment of week 2 as well as week 1.
Like all have not the same questions, bro.
But
Okay. There
all
might be
should be
some.
having same questions.
There
No,
is
no.
some randomization also that is
Anyway,
done.
let's avoid this ambiguity
Yeah.
and let's
Yeah,
discuss
yeah.
it later. But
The
it's a
thought,
good question, I guess.
It is a good question, and I think you can solve it with this inclusion exclusion principle formula that you have, and using Venn diagrams you can figure it out.
Okay.
sir, so what will be the procedure about the questions when there is given at least one fruit or at least two fruit?
But at least one fruit would not be this thing because that would just say you take the other number. Here, suppose if it is given at least one fruit is liked by 95% of the people, then of course 5% don't like anything, right? So that is actually also not an interesting question. If you are given exactly one fruit, at least two fruits, something like that, it can be complicated. I cannot think of something. Okay, let's try this.
Yes,
This
sir.
is the last thing we are going to try.
Okay, sir.
So suppose instead of this data, what is given is 40% like only one fruit,
Yes, sir.
and you have 55% like at least two fruits, which is essentially the same question, but I'm just but even this is not interesting. Then you'll add one and at least two, and then you'll get the complement. Now, I'm not able to formulate a more interesting question on the spot, but if
Mm.
something comes up, I'll let you guys know. I'll
Okay.
maybe even add it in this document, which will be shared with you.
Yes, sir.
Yeah, but
We are yet to
the
receive the documents that was discussed in the lecture 1 and 2.
right. So there is a discourse post with the link. The link maybe I can just drop in chat, or what I'll do is I'll ask for it to be added in the supplementary content of the portal page itself. So not all of you have access to discourse right now, no?
You can share it in the mail in that case.
Yeah, I don't know the mailing list. Yeah, whatever. In some way, I'll make sure
mail
that
in sense
it
like
will
in the chat window.
in the chat window. Yeah, that would be you guys would get it. I don't know if when I have the access to the link right now. Instead of me trying to look for it now, I'll make sure it is added in the portal itself so that everyone can get it. Okay, is that fine?
Yes.
Okay, sir.
Yeah. All right then. It's 10:15. I think it's time to wrap up unless you have some doubts.
Okay, sir. Thank you.
So for this PDF, sir,
So you'll be given the link to a Google Sheet where the details of the YouTube links as well as the corresponding PDFs will be all there in one place. It should be very easy to navigate that. But yeah, I was told that the link is already shared, but apparently not. So I'll make sure it is done. All right.
Yeah.
Okay
Thanks.
We'll close the session now. Good night. Bye-bye.
Thank you, sir.
Thank you, sir. Good night.
Good night, sir.